All right, here is a problem where we're finding the critical numbers of a function. So, hello, this is we're finding the critical numbers of a function. So what's a critical number? A critical number is a number C that's in the domain of the function, but either it's not in the domain of the derivative, so f prime of C is undefined, or it's in the domain, or f prime of C is equal to 0. So a critical number is in the domain of the function, but that number C, when I put in f prime, is undefined, or f prime of C is equal to 0. So one of the things that probably we should then do is check out what the domain of this function is. Although, I don't know, maybe I could avoid doing this because I'm not super excited about doing extra work. So anyway, but the domain, I think we can see once I factor the denominator, is all x such that x is not equal to -3 and x is not equal to 1, because 1 and (-3) make the denominator equal to 0. So a critical number can be any real number, well, I mean, under certain restrictions given by the definition, but it flat out from the beginning cannot be (-3) and it cannot be 1. So now we're going to find f prime of x, and we're going to see if we can find numbers where the derivative is equal to 0 or the derivative is undefined. So in order to do this, we'll use the quotient rule. I think that's just the way to do it. Surprised, sometimes there's some way to do things I never even knew about, but anyway, the quotient rule says you take the derivative of the numerator, and then you leave the denominator untouched. Then you leave the numerator untouched, or you take the difference, subtract. Numerator, you leave that alone, and then you take the derivative of the denominator. And I don't think that's going to be very difficult to do. It's true I had to remember what the quotient rule is, but once you get that, okay, derivative of the numerator times the denominator, less, or subtract the numerator times the derivative of the denominator, draw a line there, and so on and then we're dividing by the denominator squared. So that's going to give x squared minus 1 derivative, which is 2x. And by the way, a big piece of this is just, did I copy the problem down right? That's huge, right? Copy the problem down wrong, and then the whole thing's wrong. Okay, now I want to point out that right off, the denominators of the original function and the f prime are, well, they're sort of similar. But what I want to get at is that this denominator factors to x plus 3, x minus 1. And so (-3) and 1 are not in the domain of f prime. However, (-3) and 1 are not in the domain of the original function. So those, therefore, (-3) and 1 are not going to be critical numbers. So the domain of f prime is equal to the same, x not equal to (-3), x not equal to 1. So we're not going to find any critical numbers from where f prime is undefined. The places where f prime is undefined are at (-3) and 1, but those are the same numbers where f is undefined. So now we're going to move on to solve the derivative equal to 0. Now, okay, this is a fractional statement, or it's a rational function. So so a fraction is 0 a fraction equals 0 when the numerator is 0. Now, there's a little bit of a caveat to that, or something that we should be careful about. If I set the numerator equal to 0, and I get that it's equal to 0 at (-3) and 1, which are not in the domain of f prime, those are not going to be critical numbers still. I mean, the function f prime would still be undefined. But I want to just do this and just pick up the numerator so I don't have to carry around the denominator. I mean, I could. It wouldn't really be the worst thing for me. But it just might make things a little easier that way. Now, another idea is why don't I expand this right away? Well, the reason I'm not going to is because I have an idea that possibly some things will factor out. And so, see, if I multiply this out, I'm going to get a third-degree polynomial. Now, in the meantime, I got low-hanging fruit. I got 2 I factored out from both of those, and I just divide everything by 2. So that was like not a huge achievement, but I at least got that. Now, what I have okay, look, I'm wondering whether I can factor this x squared plus 2x minus 3. What do I get? I get x plus 3x minus 1. And on the right-hand side, or that other term, do I have x minus 1 as a factor? Yes. Okay, hold on. So let me make this clear. What I'm trying to do is I see that I showed this before, we saw this before, that x minus 1, x plus 3 is the factorization of x squared plus 2x minus 3. But we also have x minus 1, x plus 1 as a factorization of x squared minus 1. And so, so I have both of those as factors, and then I'm going to factor that out. I mean, it's tempting to expand this, just multiply it through and factor, but if I multiply everything through, the result will be a third-degree polynomial, which, that's sort of, something that I might struggle with. But I mean, even if I didn't struggle, why not just do it this easy way? I have x minus 1, I factor it out. So I get one factor, and by the way, apparently that x minus 1 is going to correspond with x equals 1, which is not in the domain of the original function. So all right, so that in fact, if I were going about if I kept this as f prime of x, the x minus 1 in the numerator would cancel out with 1 x minus 1 in the denominator. In the denominator of f prime, it's going to be the denominator squared. So anyway, let's keep just moving ahead on this. So I have x squared plus 3x minus the expansion of x plus 1 squared is x squared plus 2x plus 1. You can see that I had not planned to use up so much space. I'm always overconfident on how much space I'm going to have to use. Well, this is a nice little development here that x squared cancel there. So it makes me think, even if I did multiply this out, I would have resulted not in a oh my gosh. Oh, okay. Well, didn't see that coming. Also, I don't think I should put equals on the left-hand side. So this is going to give x minus 1 squared equals 0, and this gives x equals 1. But x equals 1 is not in the domain. What? Oh my gosh. Do you see all I did is I simplified the numerator, and I didn't work out this problem before, so I didn't see it coming. But we see that f prime of x, after I did all that work, is x minus 1 squared over, and the denominator is x plus 3x minus 1 also squared, and that's going to be 1 over x plus 3 squared, which so f prime of x is never 0. And moreover, the number -3 and positive 1 are not in the domain of f prime, and so but they're also not in the domain of f. So after all of that, unless I got this wrong, but this is an odd problem. I can look it up. There are no critical numbers. I feel like I got tricked. I wonder if I can just bring this up quickly. This is from Openstax, and I think it's section 4.3. And hopefully I have it right over there. 4.3, and this was, I wrote, okay, so it's 115. I click on this. That's so awesome. OpenStax, it's free. It's online, or you can get a hard copy from. But anyway, you can order a hard copy. But it's free online. Click it, and then this is the answer. Apparently, no, that didn't seem to do that. I click it again. Technology, what the heck? That's supposed to give me the answer down there. So I get to 115, none. All right, so at least I have the same answer as OpenStax, but wow, that was something. After all that giant work, what did I find? I found that when I simplified the numerator, I got x minus 1 squared, which would give x equals 1, but x equals 1 is not in the domain of the original function. In fact, if I go back then and put that numerator into f prime of x, I get x minus 1 squared divided by x plus 3 times x minus 1, all of that squared, which simplifies to x plus 3, 1 over x plus 3 squared. By the way, just because I simplified doesn't mean, there's a little tiny thing of, depends on how someone really nitpicking me, but anyway, but notice x can still not equal to 1, and obviously x cannot equal negative 3. So the f prime is never 0. F prime of negative 3 and f prime of 1 are undefined, but that's also true of f. So negative 3 and 1 are also not critical numbers. Okay, what else is there to say? I don't know. Leave a comment if you have something more to say. But all right, that's all.